Hi guys, this is Mrs. Gassler, and in this video we're going to talk about models of bonding, and we're going to show what happens when we form ionic bonds and covalent bonds. You're going to need some Cornell paper, and we're going to be drawing electron dot structures, and if you need a refresher, we did that in Objective 7 of Unit 5, so if you want to go and review that, otherwise we'll be talking about it here. Okay, so we're going to fill this out here. First, name, date, and class period here, and our topic is models of bonds. We have one essential question that we're going to answer in a variety of ways. How are electrons involved in bonding? And so to begin with, let's talk about why atoms bond. Now you might remember there's that thing called the octet rule, which we talked about when we talked about ions forming, which was just a couple of objectives ago. And the gist of it is that atoms are most stable with a full valence level. And that generally means 8 electrons. The exceptions are on that first row, hydrogen and helium are happy with 2, and lithium, beryllium, and boron have an easier time just losing their electrons to go down to 2 than getting all the way up to 8. So in order to get those full valence shells, there's 2 ways that they do it, and they either form an ionic bond or they form a covalent bond, and which one they form depends on how many valence electrons they have. We talked about how to identify what kind of bond forms, and now we'll kind of understand a little bit more why metals and nonmetals form an ionic bond and nonmetals form covalent bonds. And talk about covalent bonds. Okay, now we just talked about this first thing, and that is that the nonmetal atoms, they can't lose electrons. Remember, they gain electrons because they're almost at that full valence shell. So instead of nonmetal atoms gaining and losing, they do this thing called sharing. They share electrons. Okay, and so we're going to look at an example of fluorine and fluorine. And I got to cover something up over here. There we go. All right. So fluorine and fluorine. This is how we're going to draw this. Okay. Fluorine, I'm going to draw sort of the dot structure here and then show you. So fluorine, remember, had 7 dots. And I'm going to flip these so it's easier to see. There's my 7 dots. And fluorine, this fluorine, if it gives up an electron to make this fluorine happy, it's even less happy, so it's not giving up electrons. So what these guys do is they come together, and we do this. So we've got our pairs of 2 around, and from this fluorine's perspective, can you see that? Yeah. From this fluorine's perspective, it says, hey, look, I have 8 valence electrons. I'm happy. And from this fluorine's perspective, he says, oh, look, me too, yay. And so right here, this is where they're sharing those electrons, and that right there is the covalent bond. Okay. Now, something we need to know is that this is called a single bond because they're sharing 1 pair, which is 2 electrons total. So 2 electrons are being shared. Now we also have a double bond, which, surprise, surprise, is when they share 2 pairs, which would be 4 electrons shared. And then we have a triple bond, which is 3 pairs, which is 6 electrons shared. And we don't really talk about a quadruple bond, but I suppose they could potentially share all of those things. But that's it for how a covalent bond works. So we're sharing. So I call these, so a covalent bond is sharing electrons, ionic bond is giving and taking electrons. Okay, so how do we draw the covalent bond? All right, so I've got 2 examples we're going to look at here, oxygen and then carbon and hydrogen. Okay, so the first thing we're going to do is we're going to draw the dot diagrams, just like we did in the last one. Here's my oxygen, and here's my other oxygen. And then what I'm going to do with those is I'm going to circle the pairs that they're going to share. Now, these 2 electrons aren't going to become a shared pair, and these 2 electrons aren't going to become a shared pair. They got to share with each other here. Okay, so I'm just going to pair them up, and I draw a little loop like a rubber band holding them together. And this guy over here, this one looks a little ugly. There we go. So now it's sharing those electrons there also. Okay, so now I just have to redraw, and I'm going to replace the shared pair with a dash. So here's my oxygen, and here's my other oxygen. They're actually sharing two pairs, so I'm going to put two dashes. Looks like an equal sign, but it's just dashes. And then I'm going to leave those non-shared pairs there. Now, if I were going to draw the one for fluorine, it would look like this. I would draw an F with a dash, and then I would put three pairs around each one because there's three pairs that they're not sharing. Okay, so let's take a look at carbon and 4 hydrogens. So carbon has 4 dots, and each hydrogen has 1 dot. Now remember that hydrogen is happy with 2. Okay, hydrogen is very special. In fact, it's so special with this 2 electrons that it's happy with that we call it a hydrogen bond. And it's really a covalent bond between hydrogen atoms. But the idea is the same here. So now I'm going to circle my pairs. So this one maybe can go there. This one maybe can go there. You can connect over here. Yeah, this gets a little messy the more electrons we're sharing, but there we go. Now, when I redraw this one, I'm going to need to organize it a little bit. Everybody's connected to the carbon. Okay, so when I draw my carbon, I'm going to put it in the middle. And then I'm going to surround it with my hydrogens. Now remember, those electrons don't like each other, so it's not going to be one connected to another, or all on the same side, I mean. And then I'm going to draw my dash in between these guys. Now it's okay that my dash is up and down instead of side to side. It doesn't have to be side to side, but this is a carbon and 4 hydrogens, which I believe is methane, actually. Stinky farts. Okay. Now, something that people sometimes try to do is they'll write C-H-H-H-H-H. But this is implying, this right here says that those H's are connected to each other, and that's not what I drew up here. So this is not right. Okay, so you got to pay attention to what's connected and how, and organize it accordingly. All right, so we've got one more thing to talk about before we're done talking about models of bonds, and that is the particles that we end up with. When we talk about, oh, the lights just went out in the room. When those particles, here's our ionic and our covalent particles. We've got 2. We've got a formula unit and we've got a molecule. Okay. Now the formula unit is for an ionic bond, and it happens because all the cations attract all the anions, and what we end up with is a tightly knit, connected crystal form. That's why those ionic compounds they have high melting points, and they're pretty crystalline. They're solid structures. Okay, our molecules are for covalent bonds, and what's happening here is that atoms are only connected if they share. So we have individual little pieces. If they're sharing electrons, they're stuck together, but that's it. So those atoms aren't really attracted to each other. That's why those guys have low melting points. So the last thing we want to talk about is the difference between polar and nonpolar. Polar happens because we have unequal sharing. The reason they end up with a charge is because some of the electrons end up a little closer to one atom, which leaves the other one a little positive. And so we call it a polar compound. And the nonpolar is equal sharing. Those electrons are just right in the middle. They're sharing them equally, and so they are nonpolar. Okay, so sorry the lights went out there the last couple of minutes there. If you have any questions about how to draw these guys, make sure you ask your teacher. Thanks for watching.